Okay, this is the schematic for the LCD group. The green LED here is connected to the digital pin 2 of the Arduino Uno. The yellow LED is connected to the analog 1 pin of the Arduino. The red is connected to the analog 2 pin. And then the LCD is the same as the original project. The 5 volts is connected to the potentiometer, the VDD, and the LED positive. The 3 LEDs are all connected to ground, which is connected to the Arduino ground. The VSS is connected to ground, the RW is connected to ground, and the LED negative is connected to ground. The D7 pin is connected to the RS pin, and the D9 through D12 is connected to DB4 through DB7. On the integrated circuit for the motor, we have the enable 1 is connected to pin D5, digital pin 5. The input 1 is connected to the digital pin 4. The motor positive is connected to output 1, which is controlled by the enable 1. The negative is on output 2 of the motor, and the power supply, 5 or 9 volt power supply, is connected to ground here, and the positive of the power supply is connected to the plus V motor. The push buttons are both grounded to the power supply, and the down is connected to D13 pin. The up is connected to the D6 pin. And that's pretty much it for our schematic. Next, I will go to the code. Okay, this is our group's code for the project. The screen is an LCD display, and it uses a 16 by 2 grid. The grid is 2 rows of 16 columns. The LCD display will show the pulse width modulation value that is powering the motor, and the motor variable for the PWM value, and the 2 push buttons for changing the value. The letters PWM will be printed next to the motor output variable. The LCD indicates when the motor's on and off by showing a custom on character when it's receiving power. The on character is shown in column 15, row 0, which is the top right of the screen. The LCD shows the up or down arrow when the push buttons are incremented up or down. The arrows show up in columns 0 and 1, and that's in row 1, which is the bottom left of the screen. And the screen also shows the change in value when incremented or decremented. There's a green LED to indicate the motor's on, a yellow LED to indicate that the motor's running within the proper limits, and a red LED that lights up when the motor is over a set limit. A potentiometer is also used to adjust the the contrast of the screen. This line right here is to include the library, the liquid crystal library. This row is making the up push button as a variable, and it's set to pin 6. This is the down push button variable, and it's set to pin 13. These also set pins. This is the enable for the motor, and it's set to pin 5. This is direction 1 and direction 2 of the motor, set to pin 3 and 4. This sets up the green LED integer, and it's set to pin 2. This is the motor variable, which shows the output of the motor basically, and it changes when incremented or decremented. This is just the pins used for the LCD. This right here is the on custom character. It's an array, and it uses 8 rows of 5 per row. And you just fill in ones for the custom character. Whichever one of these has a 1 will be lit up on the screen. This is the custom character for the up arrows, or arrow. Same thing, just put 1s in to make it look like an arrow. This is the custom character for the down arrow. This just initiates the serial monitor so that you can troubleshoot or see what's going on. This initiates the up push button as an input pull up. This initiates the down button as an input and pull up. This initiates the enable as an output. And this is the 2 directions of the motor as outputs as well. This creates the on custom character, and it's set as 0. This creates the up and the down, and they're set as 1 and 2. And then these are the analog pins, and they're set up as outputs. This line right here just sets up the LCD's number of rows and columns. The next one sets the cursor at 0, 0, which is column 0, row 0, which is the top left. This prints the motor variable, which is the pulse width, and it changes as incremented or decremented. This sets the cursor at 5, 0, which is column 5, row 0, and it just prints the letters PWM. This is the up push button if it's low, which means when it's pressed. If it is pressed, then the cursor is set to 0, 1, column 0, row 1, which is bottom left. Bottom left. And it shows the up arrow, which is the byte 1 right here, calls on the up arrow, this one. It also changes the motor enable to the value of the motor variable so that the motor is powered by that amount. And then there's a delay. And then if the down button is pressed, the cursor sets the position 1, 1, and it calls on byte 2, which is the custom down arrow. It also decrements the motor. And this one also increments the motor right there. And then it sets the value to enable, or sets the motor value to the enable. Serial print is just printing out the motor value so you can troubleshoot or look at it in the serial monitor. If the motor is greater than 0, cursor set to 15, 0, the on custom character is called and used in the top right corner. Also, the green LED is set to high. If the motor is less than or equal to 0, the green LED is turned off. If the motor is less than 0, motor equals 0, just resets the motor value so it doesn't stay negative. If the motor is greater than or equal to 200, then the red LED is set high using the analog 2-pin. If it's not, then it's set as low for the red LED. If the motor is greater than or equal to 90 and less than or equal to 200, then the yellow LED is turned on. If not, the yellow LED is turned off using pin A1, the analog pin. The value is then set to the enable so that the motor can run at the correct power. And then motor direction 1 is not used, so it's set to low. Motor direction 2 is the one we're using, and it is set to high. And that's it for the coding.